Hey guys, we are working exponential growth and decay problems. Let's look at the first one. The rate of change of p is proportional to p when t equals 0, p equals 5,000, and when t equals 1, p equals 4,750. What is the value of p when t equals 5? The first thing I want to show you, and we only have to do this once, is how the exponential growth and decay equation is derived. Let's break this down, that first sentence. It says the rate of change of p. Well, I know a rate of change, that's the change in p over the change in time. That's a rate, right? I could also rewrite that as p prime if I wanted to. The rate of change of p is proportional to, so it's equal to some proportionality constant, it's a k, and it's proportional to p. So I have this equation right here. This is a differential equation, and I know that I can solve this differential equation by writing p prime as this, moving dt over, bringing p over to the other side. Let me clean this up a little bit. What I've got is 1 over p dp equals k dt, and then I integrate both sides. The integral of 1 over p is the natural log of p, and the integral of k with respect to t is just going to be kt, and then we'll put plus c on this side. And then to solve for p, I would raise both sides to the e. I'm sorry, I would do e raised to both sides. It's called exponentiating both sides. So I have that p is equal to e raised to the kt plus c. And if I think a little bit more about this exponent here, I can rewrite that. I know that when I multiply like bases, I add the exponents. Here the exponents are added, so if I go backwards, I can say that that's multiplying. So that's e to the kt times e to the c. And e to the c, I'm just going to call that c. So I have that p is equal to c e to the kt. Once you know that that's the exponential growth and decay equation, you can go straight to that. But I think it's a good exercise to show that at least once. Now let's go back to what the actual problem said. It said that when t equals 0, p equals 5,000. That 5,000 is my value for c. c is the initial amount, but we can prove that. You don't have to take my word for it. It said that p is equal to 5,000, and then I have c equals c e to the k, and then t was 0. Anything raised to the 0 power is just 1, and so there you have it. C is 5,000. So I can add a little bit to my equation here. I can replace c with 5,000. Now before I can solve anything else, I need to find k. And so these problems will always have to give you some sort of data point to where you can find k, and it does give us a data point. It says that when t is 1, p is equal to 4,750. I have a value to plug in for t. I have a value to plug in for p. I can solve for k. Let's do it. So I have 4,750 equals 5,000 e to the k t. But we know that t is 1. So if I go about solving for e, first thing I can do is I can divide by 5,000 on both sides. I'll get 0.95. That decimal came out nicely. If you end up with a really long decimal, carry out a lot of decimal places. You will get better results in the end the more decimal places you carry out here. This is obviously a section where you can use a calculator, and it would be like that on the AP test as well. Now to solve for k, I need to get rid of the e, so I'm going to take the natural log of both sides. When I type this into the calculator, that goes away, and I get that k is equal to the natural log of 0.95, and I get negative 0.051293. I can probably get away with stopping there. Once again, the more decimal places you carry out, the better your final answer is going to be. So I have a nice complete equation now. I have that P is equal to 5,000 e to the negative 0.051293 t. Now what I can do, I can plug in any value for t and get the value for p, or I could plug in any value of p and solve for t. And what the question asks us to do is to find p when t equals 5. So all I have to do is plug in 5, type it all in the calculator, and I get a final answer of 3,868.91. Done. Let's do another example. Chemistry! There's a chemistry way to solve half-life problems, but we will solve them the calculus way. It says radium-226 has a half-life of 1,599 years. After 10,000 years, 0.1 grams of a sample of radium-226 remains. How many grams were initially present? We've already gone through the derivation, so I know I can find, or I can start with this equation. And I know that C is my initial amount. How many grams were initially present? What I'm looking for is C. That's what I'm trying to solve for. To be able to do that, I've got to have a value for K. And I need a data point to solve for K, and I do have a data point. It says after 10,000 years, 0.1 grams remains. That's not going to help me if I don't have C, right? So I need to use some other piece of information, and here's what I have. It has a half-life of 1,599 years. So I could start with any amount that I wanted to. Let's say I started with 100 grams. After 1,599 years, I will have half of that remaining. I could pick any values I wanted to here, as long as this one is half of my original amount. Now I can go about solving for K. So I'm going to divide both sides by 100. And you'll see that no matter which two values you chose here, you should end up with 0.5 equals the natural log of, oh no, I'm not ready for natural log yet, equals e to the kt, and I know my t here is 1,599. To go about solving for k, I take the natural log of both sides. The natural log of 0.5 is negative 0.693, and that's the part that should look like chemistry, equals 1599k, and divide by 1599, and I get that k is equal to negative 0.000433. Now, if you loved chemistry so much and you remember that formula and you can write down the answer for K without doing any calculus, then that's great. And I'm all for it because that makes me proud. But if this was an open response on the AP test, I would do it the calculus way, just to be safe, just to make sure you get your points. Now that I have a value for K, I can say y equals C e to the negative 0.00433 t. Now I can use my data point to solve for C. It said that I had 0.1 grams after 10,000 years. Now I can solve for C. So if I type in this number and I do 0.1 divided by whatever number that is, if I do 0.1 divided by that number, I get that C is equal to 7.59 grams. When you can, it's always nice to include units. When you can.